You are cruising down the highway at 70 miles per hour. Your favorite playlist is on, and you are entirely unaware the 4 small patches of rubber keeping you on the asphalt are currently undergoing a thermal breakdown that could ruin your entire week. Most drivers treat their vehicles like household appliances, turning the key and expecting perfection. But the physics at play underneath your floorboards tell a much more violent story. Let us start with the only thing connecting your 2-ton machine to the road. Your tires are subjected to immense dynamic forces that can exceed 4 times the weight of your vehicle during a sudden lane change or panic stop. Running your tires with just 10% less air pressure than what is printed on your door placard does not just hurt your fuel economy, though it does increase rolling resistance by a massive 15%, forcing your engine to work much harder just to maintain a constant speed. The real danger is what happens inside the tire structure. Underinflation causes the tire sidewalls to flex excessively with every single rotation. At highway speeds, this rapid flexing generates an intense internal heat that breaks down the chemical rubber compounds and compromises the steel and nylon belts inside the casing. You are essentially cooking your tires from the inside out. Eventually, this heat causes the internal layers to separate, creating weak spots that lead to catastrophic blowouts at high speeds. On the flip side, if you overinflate your tires thinking you will get better miles per gallon, you are ballooning the center of the tread, drastically reducing your contact patch with the road. This concentrates all the wear right down the middle and makes your car dangerously slippery in wet conditions. Getting a cheap tire pressure gauge and checking your tires once a month optimizes your grip, maximizes the life of the tread, and keeps you out of the ditch. Speaking of weight and forces, we need to address how you are loading your vehicle, because your daily driver is not a heavy-duty freight train. Every extra 110 pounds of useless junk you carry in your trunk or cargo area translates to over 1,100 pounds of additional stress on your suspension system during an emergency braking maneuver. When you overload a vehicle, you are forcing the suspension geometry completely out of its designed operating range. The springs compress too far, resting on the rubber bump stops, and the hydraulic valving inside your shock absorbers takes an absolute beating. If you take a standard compact crossover and load it with 900 pounds of concrete mix from the hardware store because you think it has the cargo space of a Ford F-150, you are going to destroy your ride quality. Within a couple of months, you will be dealing with blown shock absorber seals, leaking hydraulic fluid everywhere, severely sagging coil springs, and bent control arms. This completely throws off your wheel alignment, causing your tires to wear out unevenly in a matter of weeks. Every vehicle has a gross vehicle weight rating, or GVWR, printed on a sticker right inside the driver door jamb. If you subtract the curb weight of your empty car from that GVWR number, that gives you your maximum payload capacity. And yes, the weight of you and your passengers counts against that limit. Clean out your trunk, travel light, and stop treating your independent rear suspension like a solid axle work truck, because overloading will physically tear your chassis apart, starting right from the wheel bearings. Before we dive into the engine bay to look at the silent killers that cause catastrophic mechanical failure, if you want to learn how to keep your ride out of the repair shop and save yourself thousands in mechanic bills, go ahead and hit that subscribe button to join our garage community. Now, let us talk about the lifeblood of your engine and how ignoring it destroys the most complex systems under your hood. Modern engines rely heavily on variable valve timing to give you both low-end torque and high-end horsepower. Whether you are dealing with a complex BMW Vanos system or the cam phasers on a modern Ford Coyote engine, these systems operate using engine oil pressure to hydraulically advance or retard the camshafts. They rely on incredibly tiny oil passages and delicate solenoid screens to function. When you stretch your oil change intervals too far, or if you use cheap conventional oil instead of the required full synthetic, the oil breaks down and forms thick, abrasive sludge. This sludge gets pumped directly into your variable valve timing solenoid, clogging the microscreens and restricting oil flow to the phasers. You will start to hear a nasty mechanical rattle on cold starts. Your idle will become incredibly rough, and your check engine light will illuminate with cam timing codes. Replacing these phasers, or rebuilding a Vanos unit, is a painfully expensive job that can easily run you over $2,000 in parts and labor. The absolute best way to protect these hypersensitive hydraulic systems is to ignore the overly optimistic 10,000-mile oil change intervals printed in the manual and drop your oil every 5,000 miles with a passed, high-quality filter. Moving deeper into the combustion chamber, we have the spark plugs, which are small components that single-handedly dictate the health of your entire powertrain. A spark plug has a brutal job, firing thousands of times a minute inside a chamber filled with explosive pressure and blistering heat. Over time, the precious metals on the tip of the electrode physically vaporize, causing the crucial gap between the center and ground electrode to widen. As this gap grows, your ignition coils have to work twice as hard to generate enough voltage to jump the spark across that wider distance, which prematurely burns out the dielectric insulation inside the coils. But the real nightmare begins when the spark becomes too weak to fully ignite the compressed air and fuel mixture. This creates an engine misfire. The unburnt, raw gasoline washes the protective oil film right off your cylinder walls, accelerating piston ring wear. But worse, that raw fuel gets pumped directly out of the exhaust valve and straight into your catalytic converter. Your catalytic converter is a ridiculously expensive piece of emissions hardware, filled with precious metals like platinum and palladium. When raw fuel enters the converter, it superheats and literally melts the internal ceramic honeycomb structure into a solid brick, choking off your exhaust flow entirely. Replacing a melted catalytic converter can easily cost you upward of $1,500, especially if you drive a turbocharged or direct-injected car where carbon buildup is more aggressive. You cannot neglect your ignition system. Stick to high-quality OEM replacements like NGK, Denso, or Motorcraft Iridium plugs and swap them out every 60,000 to 70,000 miles before a weak spark burns a hole in your wallet. While we are discussing expensive neglect, let us touch on a fluid that most people never check until steam is billowing out from under the hood. Your engine coolant does a lot more than just keep the block from melting down. It actually contains a highly specific cocktail of anti-corrosion additives designed to protect the mixture of cast iron, aluminum, and copper components within your cooling system. As the miles rack up, these chemical additives break down and become completely depleted. When this happens, the coolant literally becomes acidic and starts to act as an electrolyte. Because you have dissimilar metals touching the fluid, your entire cooling system turns into a giant, low-voltage battery in a process called galvanic corrosion or electrolysis. This acidic fluid begins eating away at the aluminum inside your radiator, destroys the impeller blades on your water pump, and rots out your heater core from the inside. You might notice your heater stops blowing hot air in the winter, or you find a puddle of sweet-smelling fluid under the car. Flushing your cooling system every 50,000 miles with the exact specification of coolant required by the manufacturer is the only way to replenish those anti-corrosion inhibitors and stop the metal inside your engine from being slowly digested. We are about to cover the single most destructive failure that can happen to your engine without any warning whatsoever, the kind of failure that turns your car into a giant paperweight. But right before we get into the mechanical violence of a snap timing belt, make sure you subscribe to the channel so you do not miss our next deep dive into keeping your vehicle running forever. The timing belt is a hidden, reinforced rubber tooth belt that sits behind a plastic cover on the front of your engine. Its sole purpose is to keep the bottom half of the engine, the crankshaft and pistons, in perfect mechanical synchronization with the top half, the camshafts and valves. Most modern power plants are what we call interference engines. This means that the pistons and the valves share the same physical space inside the cylinder, just at different times. If the timing belt snaps while you are driving at highway speeds, the camshafts instantly stop spinning, leaving some of the valves stuck wide open. The crankshaft, however, keeps spinning from the momentum of the car, and the pistons slam violently into the open valves at thousands of revolutions per minute. The valves get bent into pretzels, the pistons get shattered, and the cylinder head is essentially destroyed in a fraction of a second. The terrifying thing about a timing belt is that it almost never gives you a warning. It does not squeal, it does not throw a check engine light, it just breaks. The rubber ages, becomes brittle from the intense heat cycles under the hood, and gets weakened by any minor oil leaks from the front main seal. You absolutely must replace this belt, along with the water pump and the hydraulic tensioner, every 60,000 to 100,000 miles, or every 7 years, whichever comes first. Do not gamble with the timing belt, because losing that bet means you are buying a completely new engine. Maintaining a vehicle does not mean you have to be a master mechanic with a garage full of expensive tools. It just requires an understanding of how these systems rely on each other, and the discipline to handle preventative maintenance before a minor wear item turns into a catastrophic mechanical failure. Whether it is keeping a close eye on your tire pressures to prevent a high-speed blowout, respecting your vehicle payload limits to save your suspension, staying ahead of oil sludge to protect your variable valve timing, changing your spark plugs to save your catalytic converter, flushing your coolant to stop internal corrosion, or replacing that critical timing belt before your engine eats its own valves, you have the power to make your car last for hundreds of thousands of miles. I want to hear what kind of maintenance headaches you are currently dealing with in your own garage. Drop your car's year, make, model, and any weird symptoms or fault codes down in the comments below, and I will do my best to help you diagnose it. If you found this breakdown helpful and want to keep learning the real secrets to automotive longevity, hit that subscribe button one last time, and I will see you under the hood in the next one.